All right, folks. Can we get started? Well, I'm John Umhafer. I'm Executive Director of Wisconsin Cheesemakers Association, and welcome to our free member webinar series. I've got with me, and you'll see another face soon, Grace Atherton, our Director of Communications from our staff today. And we've got three major players in the dairy industry with us today who've agreed to share cutting-edge ideas and innovations in dairy plant construction. So a simple format today. After a brief introduction, you're going to hear talks from ISG, Miron Construction, and C.D. Smith Construction. These are all national leaders in food and dairy plant engineering, design, and construction. And during these talks, we'll ask you to consider any questions you have for our speakers, and let's use the chat area. Please write your questions in the chat area. Now, we're going to take your questions after all the speakers have presented. So that's our next step. We're going to have all our speakers present in turn. And then we'll have you to chat, or we will allow you to unmute and give us a question aloud if you like. So chat or verbal is just fine. We are recording this session, and the recording and the PowerPoints and the speakers' names and contact information will be available on the WCMA website. We have a resources page, and on that page you see webinars, and there are all the webinars we've had for the last 3 years, including this one, which will be up by about the end of the week. So you'll have a chance to view this anytime you like. So I'm sure you're all muted now, and we're going to jump into the presentations. And remember to chat us your questions. So I'm going to begin by introducing our team from ISG. I'll introduce their presenters, and they'll take a chance here, an opportunity to grab the screen share with their presentation. So first we have Rachel Kloos, and she's Water and Wastewater Group Leader for ISG. I sense ISG is pretty excited about Rachel because her bio says she's forward-thinking, detail-oriented as a project manager with more than 20 years of experience in process and environmental engineering. She has specialized expertise in dairy industry water and wastewater compliance and optimization to reduce facility water use and carbon footprint. Rachel holds 2 patents for water recycling and biofuel facilities and brings specific expertise in biogas recovery and utilization. And joining Rachel from ISG is Brian Gjerde. Brian is Vice President of the Food and Industrial Business Unit, and he has over 2 decades of experience designing food processing facilities. Brian has served a diverse range of clients in the cheese and dairy industry, and his significant portfolio of food and processing and production facilities has equipped him with the strategic knowledge required to collaborate with project partners, optimize dairy operations, and navigate regulatory requirements. Brian's engineering expertise allows him to balance client requirements with production schedules and budgets to streamline projects and deliver viable solutions for his facilities. So Rachel and Brian with ISG will be discussing weaving sustainability goals and new imaging technology into your dairy plant renovations and construction. And here they are. So I'll let you folks take it away.
Thank you, John. Excited to be here today. And just a quick overview of ISG. We're a full service engineering and architecture firm specializing in civil engineering, structural engineering, mechanical engineering, electrical engineering, water, wastewater, and refrigeration engineering as it relates to the cheese and dairy industry. We're excited to be celebrating our 50th year this year. Our expertise and experience within the cheese and dairy industry has allowed us to work across the United States in a variety of different projects, ranging from renovations to expansions to new construction. And with everything going on today, sustainability within these projects has become front and center in many of the opportunities and challenges that we're presented with in navigating our various projects. Rachel, if you want to jump in.
All right, thanks, Brian. So establishing your The definition of sustainability is the ability to maintain at a certain rate or level. Today, sustainability takes on a new refined definition, specifically the avoidance of the depletion of natural resources in order to maintain an ecological balance. Establishing your own definition of sustainability is going to be some combination of both of these definitions. These goals are defined by the wants and needs of your facility, your employees, your customers, and your community. Those goals are going to be different for everyone. And we recognize this. This makes sustainability a little bit squishy. And I like to use that as a very technical term. Often feels unattainable and unreachable. It sometimes doesn't feel the same as black and white and metrics, which is why the first step of any sustainability plan, as you're thinking about renovations and greenfields, is to establish your sustainability plan and establish goals and put them into metrics. Remember, the definition is broad. Avoidance of the depletion of natural resources is our plan to reduce the use of natural resources like fossil fuels and water. Is our plan to reduce harmful greenhouse gas emissions. There is no wrong answer here. We're all good. It's all good for the planet and often good for our bottom line. We must remain sustainable, i.e. we got to use our first definition, which is we need to maintain at a certain rate or level. So the first thing that we're going to do is we're going to establish a map of our sustainability plan. On the screen here, we're showing just an example. We focused on our greenhouse gas emissions. Remember, the idea of greenhouse gas and thus focusing on our global warming potential are placed on CO2, methane, nitrous oxide, and fluorinated gases. Think of the greenhouse gas as creating a level of insulation around the earth. Some is good and some is essential, but too much traps the heat on the earth's atmosphere, thus raising the atmospheric temperature. Greenhouse gas is a careful balance. Too little in the atmosphere is like stripping the insulation off of a pipe, and the atmosphere is colder, requiring more energy to heat. By mapping where our sources of emissions are coming from and what we have direct impact on, we can then establish a holistic plan of attack. We focused here on three major direct greenhouse gas impacts, which are fuel use and transportation and fleet, refrigeration, utilization and leaks, and fossil fuel utilization. So those are the direct emissions. Those are things that we have direct control of at our facilities. The indirect emissions, which are also going to be a huge part of your overall sustainability plan, would not be emitted without your impact, meaning that they're not necessarily in your control, but they are essential in your entire sustainability plan. Examples like energy and chemicals utilized to treat and transport the water to your facility, or the electricity that feeds a plant, or the more important, the raw material like milk coming into your facility and how that was produced. Now that we have a basic plan, we can move into how our plan operations and goals interact with direct and indirect emissions. Now we're going to laser focus on direct emissions. We categorize the impacts on our greenhouse gas footprint. This is the category in which we can make the largest impact, doing more with less. Establishing based on our sustainability plan, we can identify what types of fuels and, more importantly, operations and their use have the biggest impact on our greenhouse gas footprint. Is it eliminating the use of natural gas or electricity? What is our largest impact? And again, this just focuses on let's map it out. And we talk about mapping out our operations so that we can understand how do we move forward with our sustainability map. So step one of that is establishing a baseline and what metrics are going to be used for that impact. Get the entire team involved in these metrics and understand how the operations impact greenhouse gas and your sustainability plan. There must be a starting point. This is often the step that gets stepped over when we're looking at renovations, improvements that we're making. We have to have a starting plan. Oftentimes, our sustainability plans start with a 50% reduction goal. But what does 50% mean when we don't have that baseline established? The second step of our sustainability plan is what problems are we trying to solve? Maybe it's a greenfield project or a renovation. What are the opportunities for improvement? Is it seasonal? Is it a production line base? Is it different types of material that are coming in? If we have an established greenhouse gas metric, we can calculate the usage we need to obtain. And then finally, step three, With a metric and an identifiable goals, we can hone in on where we want to make improvements. So this map just kind of hones in on different ideas and brainstorming ideas as we start to build our sustainability roadmap. Second item is those indirect emissions. They're just as important in the model, and identifying, for example, that every sustainability plan is going to look at indirect emissions a little bit different. It's important for you to understand how those are going to impact the sustainability plan. A good example of that is electricity. Midwest purchased electricity is often 40 to 60% coal-based, and thus the emissions are calculated as such. Several electricity suppliers can now provide and document 100% wind-generated electricity for a couple of cents a kilowatt, of course. But on paper, that could mean that your purchased electricity is 100% wind. Does that fall in line with how your sustainability plan is written? And could that work into your model? That helps us focus on some of those indirect and direct emissions. Does this work in your model? We can also recognize the impact of emissions from the farm and how that impacts the total sustainability plan. Again, establishing those metrics arms the facilities with the information necessary to start those conversations. Finally, bringing all these metrics together, we can now work on solutions and establish a roadmap. There are real efficiencies and justifiable projects in automation, for example, compressed air operations and high efficiency equipment. Those are real numbers we can put numbers to. So let's look at a couple examples. Here's an example of a review of a facility in which we looked at the overall, we were focusing on natural gas and electricity, and we looked at the overall megawatts used of natural gas electricity utilization. So you can see the gray trend showing that baseline. And we made some recommendations by looking at different technologies to say, hey, let's look at a couple different technologies and see what we can do and to reduce that energy usage over a 365-day period. You can also understand that those metrics are really important. In order to hone in on some of that technology, we had to look at the trends and understand where we were utilizing this energy. We understand that some of this was seasonal relative to cooling and heating cycles. So that's going to change the different types of technologies that you can look at. This allows us to put together an overall sustainability roadmap in which we can look at different technologies, for example, geothermal cooling, understand what that capital cost improvement would have, any impacts on operation costs, and if there was natural gas offset, as well as the CO2 equivalent offset that would be produced over the year. This, now arms the facility in being able to make good and valid decisions on moving forward with our construction projects. In summary, that sustainability roadmap allows a facility to look at whether it's a remodel, a new facility, or anything, looking at different technologies and understand what that means for your CO2 equivalent offset. Again, that metric ton, however is written into your sustainability plan, as well as understanding the other definition of sustainability, meaning that we've got to make sure that it's got a good payback and that it can look good in the long run for our bottom line.
Just kind of wrapping up here quick, some of the technology used to help in the design of some of these projects starts with some 3D scanning. We're able to quickly and accurately capture accurate as-built information of existing facilities, specifically in GMP areas where it's a non-obtrusive way to get into the space and get accurate documentation that we can then bring back and number one, use the scan data to accurately take measurements and reference back to what conditions there are within the existing facility, but then also build that into the 3D model that we're using for the design so that we have as accurate drawings as possible, which then builds into being able to work with the construction partners like Miron and C.D. Smith to be able to share those models in further development and planning for these facilities that are highly complex. There's a lot going on to do a better job of planning. An additional item too that has proven useful for us in leveraging that technology is the LiDAR for aerial surveying that is survey grade, as well as thermal imaging to very easily and quickly diagnose potential issues within a facility from the exterior in hard to access locations, and be able to target some potential problem areas without a lot of extra work. So just a couple quick examples of other ways we're leveraging that technology as well. But kind of key takeaways from a sustainability standpoint: number one, establish the goals. Number two, identify and prioritize solutions. And three is implement the solutions. And appreciate the opportunity to talk to everyone today, and we'll be turn it over to John and to the next group.
All right, thank you very much, folks. We will shift over then to Miron Construction. We've got with us today Logan Krueger, VP Business Development in Food and Beverage, and presenting is Sam Tijan. With more than 25 years experience in architecture, engineering, and construction, Sam leverages his wealth of knowledge working with designers, engineers, owners, and contractors to find solutions to project challenges. In his role as Senior Virtual Construction Specialist at Miron, Sam assists the construction services team by facilitating 3D coordination and assembling 3D content modeled by others. He provides model management of clash detection and conflict identification and resolution, as well as manages models through updates and design changes. Sam will be discussing the benefits of new 3D and augmented reality technologies in dairy plant design and construction. So we're very happy to have you folks with us today. Take it away.
There we go. All right. Thank
I am not getting audio. I don't know about others.
Yeah, I think we might have some
How
audio.
about now?
That's
There
better.
we go.
All right, awesome. Sorry about that. I guess. Extremely excited to be here today and share a little bit about what Sam and his team are doing on the virtual construction side of things, specifically on some precast projects and the process in which we go through to core through non-core zone penetration, and then what we're doing in terms of field installation verification.
Okay, so we'll start with the non-core zone penetrations. So as many of you know, a lot of these facilities are constructed out of precast concrete panels. One of the challenges that we have during the design and then also during the construction phase is figuring out where to route all the systems that are internal to these buildings. So in an attempt to do that, ownership sits down with the engineering group and tries to design as many of these designated core zones in the precast, and sets up those planks so that you can core through holes to run piping through, conduits, ductwork, things of that nature. So what you're seeing on the screen on the left-hand side is these designated core zones are openings in the precast, depending on how that's done. And the ideal state is that everything lines up to move through those. What we end up experiencing in the field due to a myriad of different things, whether that's changes in equipment, additional piping that needs to be done, additional controls, a lot of factors come into play, and what ends up happening is we inevitably get to a situation where we need to route beyond or outside of those designated core zones. So currently, that's a really lengthy process to review and approve those non-core zone penetrations. What happens now in the field, we can go to the next slide now. Our trade partners will get the information that they need, start trying to figure out during our BIM coordination process where that routing is going to go. Trying again to hold to the design intent as much as possible. What typically happens then is they find the area that they need to core through, and they'll submit an RFI to the engineer. Typically they're doing this based on the construction documents that they have in front of them. So elevations from the architect and engineer, showing a location. That information then goes back to the precast concrete engineer. Unfortunately, they're typically referring to a different set of documentation in terms of what the actual ID of the plank is, where that's located. So oftentimes they'll request additional information and have the trade partner mark up the actual shop drawing or pour drawing from the precast supplier. That gets marked up, and the engineer reviews that. Oftentimes, they're just marking a hole in there, not really knowing what's going on from a reinforcement standpoint. So there's often a lot of back and forth conversation with that. So this process can last anywhere up to 2 weeks typically. And our project management team asked us if there was any solutions to try and come up with to not necessarily mitigate this process, but certainly reduce the time it took to get this information in front of the right people at the right time. So what we've done in-house in our virtual construction department is we've taken the models now that we get from the precast suppliers. And it's an interesting note. 5 years ago, we probably weren't in a position with most of our precast suppliers to do this, but now many of them across the country are creating pretty extensive 3D models of their precast plank. Not only is the model constructed and showing what's going to happen from an overall building standpoint, but those models have detailed parameters, what the plank ID is. So now we're able to connect those actual pour drawings that they send us to elements in the plank. So that's what you're seeing here, that plank that's highlighted there. We can click on that plank. It links the trade partner then, or whoever's looking at the model, to the PDF of the pour drawing. This enables our trade partners to analyze that piece of plank for where they're looking to core through it. Is there reinforcement there? Are there pick points that were there? All of these things that could factor into whether or not the engineer is going to approve them drilling a hole through the plank in that particular location. And then to expedite the process, they're marking up on those pour drawings, sending that to the precast engineer. So now we have an engineer who understands what document they're using, exactly where it is in the project, and what the implications are of where that requested location for drilling is. We've taken a process now that typically lasted 2 weeks previously, and we've brought that down to a day or two now to get turnaround, which is invaluable to our schedules and to our conversations during coordination for sure. So the benefits are, as I highlighted before, the first one is we're now putting our trade partners in a position where they're reviewing these precast plank and understanding what the implications are of the area that they're looking to drill through. So we're not asking an engineer if we can core through a spot where they've got a ton of reinforcement that's critical to that plank structure. Some of these reviews are showing that maybe it's a better idea to try and push this routing somewhere else and try and get back into that core zone. I think it reduces the number of maybe unnecessary RFIs. And then the biggest factor in this whole thing was the reduced turnaround in the time of these discussions. So it's not a back and forth, it's information that's being provided in the right place at the right time, drastically reducing the time it takes to get these RFIs approved. And then along those same lines, again, trying to leverage this coordination effort that's going on in the BIM process, trying to utilize that model information when it comes to verifying where things get installed in the field. The current state or the previous state was that we would do the BIM coordination process. When we got an area coordinated, the trade partners would produce installation drawings and we would sign off on that area, meaning that we're coordinated, these are where our systems are going, And now we're giving you documents that we are going to distribute to our field teams to show them exactly where to install our systems, whether that be hangers or racks or piping or ducts or all of the above. What would happen then on large projects like this, things are going at breakneck speed. There's a lot of people in that facility during construction times, and inevitably something gets installed potentially not where those coordinated or signed off installation drawings were. In the past, for our field team to try and disseminate what's actually going on there, they would use the 2D installation drawings, either printed or on their tablet, and then have to look up at a spot and see if something was installed in the wrong spot. The picture that you're seeing here on the left, we've got a run of rack that's almost 200 feet long, and the incident here, the challenge here was that some of the refrigeration pipe got moved, and what it affected was probably close to about 150 drops from the fire sprinkler system. So on the left, those drops aren't shown in that real photo, but in the model, you can see where these drops go. And what happened was that the pipes, refrigeration pipes that were modeled in a certain spot got installed slightly off of that. Again, that process took probably weeks to get some measurements up there, get a lift up there that was approximately 28 feet off the finished floor. So it was just a really long, drawn-out discussion to figure out what the actual challenge was. So what we started implementing with our teams recently is utilizing augmented reality. So high level, what we're doing is taking that coordinated model that everybody's signed off on. We're loading that up to a space where our field teams can access it with their iPads. And in that model, we have targets located throughout that allows us to, in the field, place a target to a known specific location. We're aligning that target with the model on our iPads, and then it's allowing the model content to align with the actual built environment. So effectively, we're overlaying our coordinated model on what is already installed in the field. So in this particular image, you can see that there's holes in the precast plank. And right now, we're seeing the pipes that are installed there, or what was coordinated to date. And our field teams, in this particular instance, it's the superintendent, was able to take the iPad, show what was in the coordinated model to date, and show that these pipes were actually lining up with the holes that were drilled in the precast concrete plank. So pretty neat stuff. So the obvious benefits of this is, the first one, and this was kind of our target for all this, is to quickly and easily identify who is responsible for any of the discrepancy that we see in the field. So if a pipe or a duct or a conduit or a hanger is placed in a spot that wasn't coordinated initially in our process, we're able to identify what system that is and who's the owner of that system. It also reduces the verification time in the field and the discussions and the additional meetings that we have to have. As I pointed out before, that particular instance with the fire sprinkler system and the refrigeration pipe was not in a convenient spot to get to. You had to be on a lift. We're talking 200 feet of racking. So there was a lot of factors into it, and just the time frame to get documented what's incorrect or what's actually there, convey that back to the team, and then have discussions. That can add weeks to that particular challenge. So in this particular instance, using that augmented reality and the coordinated model that we have there speeds that process up. It takes that element of trying to figure out who's responsible. It just makes it crystal clear as soon as you're looking at things. And just changes that focus from whose fault is this to here's the situation and how can we resolve this. And the feedback from our trade partners and our field teams has been great. The added benefit of this is that, and one that we weren't necessarily expecting, was that our ownership and our trade partners are really seeing the value of this BIM coordination process come to life. I think in the past it was, why are we going through all the effort of building these models and doing all this fancy stuff on the computer? what benefit is that doing to us? Well, now we can have owners, field reps, whoever it might be, looking at this augmented reality and seeing what's going on there and seeing that that effort is paying off. In these dairy facilities, there's a lot of process piping and things like that, and it's really challenging to try and, you know, look at 2D documents and see what's actually done. This allows you to see all the work that's been put in and how that effort is paying off, and so that's been a really positive outcome for us.
With that, thanks for the opportunity, and we'll send it back to you, John.
Thanks, Logan, and thank you very much, Sam. That was a great presentation. So next up, we have Alex Vikemyr. He's a project manager with C.D. Smith Construction. Alex is going to discuss key learnings from the successful construction of the Center for Dairy Research and renovation of the Babcock Hall Dairy Plant in Madison. So take it away, Alex. You are muted at the moment.
There, sorry, I had to restart or refresh my Zoom meeting there, but hopefully you're able to hear and see my screen.
Yes.
All right, so yeah, I'll just get started here. Introduction. C.D. Smith recently completed the CDR addition and Babcock Hall renovation located on UW-Madison's campus. The project was a 185,000 square foot combined addition and renovation. So phase 1 and phase 2. C.D. Smith has completed more than 200 dairy related projects, totaling more than 300 million in construction value. Just to give you a brief background on myself, again, project manager with C.D. Smith, been with us for a little over 4 years now. I have a mixed bag of experience with projects related to various commercial renovations, obviously UW's Babcock Hall and CDR additions, and high-rise apartments. Previous experience as well from another employer, been exposed to healthcare and data center construction. Just to first things first, give the group a brief overview of the project. Just some photos to flip through. This in particular is CDR's new auditorium addition. This was a pretty showcase space for CDR to have seating and conduct seminars and various teachings and conferences as well. Also in the ground level, CDR has a new training applications lab. All the tables are actually on movable wheels, so you can move the chairs in and out, give it a nice flexible space. At the head table, there's an overhead camera down on the workstation that projects out onto the TV screens in the room. And again, there's an operable partition in this room too. So just giving flexibility, can be used as 2 training spaces or 1 large combined. Next, we'll jump up to like first floor. This is what the typical process space looks like on both sides of CDR and dairy. But this instance is CDR space. This is their new raw room. So I'm sure you noticed the very large batch tanks and miles of process piping and utility piping. So a lot of equipment, a lot of large equipment to fit within the space. And another highlight piece for CDR was their new conference room that actually looks into some process area and also provides a nice view of Lake Mendota on Madison's campus here. This is where the kind of the 2 spaces blend. So where the individual is on the right-hand side is on actually UW or Babcock Hall's observation deck that overlooks the dairy plant. And then on the left side of the photo, you see new office space for CDR. So that all overlooks the Babcock Hall's new dairy plant. This is a before picture before any demolition was done on the dairy plant side. So you notice just a lot of more process piping and equipment in the way. And actually notice on that south end there, I'll take you to the next photo. That was completely gutted and demolished, and this picture on the right-hand side is a new steel mezzanine that was added to support the new CDR office space as well, which is actually right above the dairy plant itself and overlooks it. And this is more of a finished product of what the dairy plant also looks like too. So both sides pretty similar, with some slight differences in there, but I think it was pretty cool to look back on pictures while putting together the presentation and kind of remembered some of the old details and challenges that we faced. All right, so just toggling through the photos, like this one, you likely notice all the equipment and piping look like a maze within the finished space. But one thing that was major for us was to identify the equipment layouts, where these things would be placed in the building, and understand their spatial and utility needs from a planning effort. We needed to make sure that the equipment fit the space, and then vice versa, the space also fit the equipment and all the needs and challenges and demands that they required. The equipment really are greatly impacted further than just what meets the eye. Things like ceiling heights, flooring details, drain locations, utility sizes, and consumption are just a few examples of behind the scenes planning topics that we needed to integrate. You can see there's just a ton of components in each room. And my next slide, this is a snapshot, really a design document, our preliminary design document that I wanted to share, that is the exact same room as the previous photo you just saw. So looking at this design drawing snapshot, you can see, okay, we have the room parameters, and then we set each piece of equipment inside to compare with architectural and structural documents to ensure there was a proper space and cleanability around equipment in each area, and also see if there were any architectural or structural conflicts to address due to the equipment needs. Another reason these layouts were so important were just to build out each piece of equipment's procurement into the overall construction schedule, to identify and nail down delivery and installation dates. You've seen how the tanks, for example, are so large in size from some previous photos, and really needed to alter and plan for how we're going to build certain rooms, whether it was leaving some finished doors off to fit the equipment in after the fact, or in certain cases leaving some walls down in order to fit the equipment within the space first, and then button up the room with the rest of the finishes. Another example of really preliminary planning before some equipment arrived was this new spray dryer, for example. This particular piece of equipment came all the way from Denmark. So there was a ton of coordination that happened before its arrival, and planned out where we needed to actually leave out a portion of the exterior wall to be able to slide that piece of equipment inside. And then also we had to plan out a opening through the roof so we could pick and tilt at the same time, stand this unit up within the room, just because due to spatial requirements. So definitely very challenging given that the equipment came from Denmark, but early in the project, it was identified as having the longest lead time for fabrication and delivery. The international procurement was certainly new to me, as the shipment required a lot of planning and coordination between the export in Denmark and import in the US, all the trucking to get it here, procurement time for customs reviews and port fees. All those tasks played a vital role in developing the schedule for this piece of equipment and integrated into the construction project schedule as well. One little fun fact, I guess, through like the shop drawing process, on the right-hand side, you'll see I took a snapshot from some RFI items, but during shop drawing review, I think it was more of a language barrier, language difference between Denmark, but they made a big deal out of this explosion vent clearance, and I always thought that it was just kind of funny because when you hear the term explosion, something bad could really happen here, but it was essentially a pressure relief vent. But when we compared the equipment drawings to some of the architectural drawings, the piece of equipment needed a secondary dedicated duct, and there was a wall penetration needed for that vent to flow out of the building. So that wasn't originally planned for. So just reviewing equipment drawings versus architectural space and comparing the two, there's always going to be a few conflicts, but we identified it ahead of time and had that penetration planned for. And once the equipment arrived, it was able to be a smooth transition in getting all the final connections addressed. Another piece of really European equipment here is you'll notice in these cheese rooms, there's a little unit on the right-hand side. That is a hygienic air conditioning system for CDR's dedicated cheese ripening room. So each room, 12 of the rooms have these dedicated units in them to provide various humidity and temperature to age various types of cheeses. This was another international component that required extensive review for utilities and mapping out its schedule due to the long fabrication and delivery time from France. The electrical components on these were more of a particular discussion point because when we reviewed all the necessary utilities for it, European equipment doesn't quite line up with the United States UL listing. Much of the NEC electrical codes were similar, but the units did not come with a typical UL stamp, just like what we have here in the US. Anything we plug into an outlet, such as like your iPhone charger, has a little UL stamp on it. These units did not arrive with that stamp on it. So after many discussions with various inspecting agencies, some field modifications were needed to address the electrical concerns with this equipment to ensure the safety of the end users and the electrical design capacities in mind. And then also one last thing more on some electrical equipment. This is CDR's new process space. And what your eyes are probably more drawn to was the APT system right behind the Kusel tables there on the left. But what I want to point out are a couple electrical cabinets and step-down transformers here on the right-hand side. Much of the equipment in this building had all different varying types of electrical service needed, and some electrical cabinets and step-down transformers were needed to accommodate the supply of the electricity to, again, various pieces of equipment. So much of the planning effort really to find a space for those to reside was a challenge piece, but we were able to do so when really outlining after all the equipment's location on the floor plan, and then began to build out more of the, I'll call it ancillary or other accommodations for the equipment as well. So the spaces were integrated with all the components still to have all working clearances and electrical clearances around them as well. So in closing, I could talk on this project for probably hours. It was a long and challenging project. Like I said, it was fun to look back on the photos, but here are some perspective links to each, same project, but 2 phases. So I believe we'll send this out part of the closeout or closing items. But if you would like to see more information, certainly check on those links, or also feel free to reach out to myself. I hope I was able to touch on some interesting information on how we were able to source, procure, and integrate some design build process components into an active construction project.
All right, thank you, Alex. Good to see that building again. And so I'll pause to see if anyone wants to share a question verbally. I don't see any in the chat right now. We do have some questions that we had talked about with the speakers, so we've always got those, and we'll certainly finish on time. But here's a chance for you to ask a question of these experts. So I'll leave 10 seconds for that, and if not, I'll launch into a question we have here. All right. I've almost reached 10. Okay, here we go. So I want to throw a question out to Alex. Kind of work my way backwards through the speakers. So Alex, if you're ready.
I'm ready for you.
I was wondering, at Babcock Hall, you built the Babcock Hall dairy plant, the ice cream plant is a large part of its production. And right next door, right through the wall, you built an all-new Center for Dairy Research. And I was wondering if there was anything unique about having two dairy plants really side by side that was a learning for you folks or might be interesting for industry.
Yeah, it was certainly interesting. A big kind of learning curve, and this one in particular was we built the addition right next to the existing Babcock Hall building, but all of the utilities for the new addition stemmed from the mechanical rooms in the existing building. So it was like basically we had to schedule a bunch of shutdowns and outline that work in the existing building for new mechanicals that were in the renovation phase, but served the new addition. And with that too, there were different parameters we had to set like equipment at, because it couldn't fully be completed until phase 2 was done. So it was set up in like a more of a temporary operational phase until we were able to then get more of the dairy plant completed and then allow for those mechanical items to finish. And then we had to like readjust and retest and balance. So definitely very unique.
Perhaps not the way you would design it if you were going to build two greenfield dairy plants next to each other.
Nope, they would have their own everything.
All right, thank you. So I'm going to bump over to Sam and ask a question that we discussed. I was wondering, with the work you folks are doing in the 3D and the augmented reality, if you're finding that you have to teach your clients, dairy plant folk, new terminology, even new software to become a part of the team that's really benefiting from the technology. Is there a big learning curve there to understand how to use that and benefit from that technology?
I would say, John, a few years ago, yes, the training that we would have to do would be intense because it felt like everything we did was a different piece of software. That's changing. Over the last couple of years now, there's a lot of cloud-based platforms, and most of these platforms now have viewers built into them. So it's really enabling us to share this information with our owners and with any project stakeholders, whether that be vendors or suppliers or trade partners. And they don't have to have a special software, right? The information is all out in the cloud. It's in our cloud-based project site. We can have them go to that particular model and click on that model, and it opens up right in your online browser. So that's really accelerated the uptake of this information beyond our coordination teams, right? So now an owner, we can just literally email them a link. They can look at the model. We can have discussions on that. We now have owners. We had a local dairy project here, and the owners were actually utilizing those online models. We set up different views for different rooms, and they were using that in their corporate board meetings. So it's a really easy thing for them to access, and it was really neat to kind of see that jump there. And Very little training was needed to get them up and running with that.
It's a great answer. It sounds like it's not a big hurdle as far as having to buy or learn the software. It sounds like it's plug and play or
Sure.
online and play.
Yeah,
So
right.
let me keep Grace hopping here and go to ISG, Rachel and Brian. And I'm gonna try to fit in a question here before we close things down. Curious folks, what percentage of your clients in the last 2 years, and then asking in the last 1 year, have been talking about sustainability when they talk about doing a renovation? Is it on the rise as through time?
Oh, yeah.
Yeah, definitely. I think just the global marketplace and all the events of the last 3 years, the awareness of it, I think, has heightened the awareness and in what we're working on, probably brought more of the conversations into the forefront. Clients and, ourselves included are much better educated on, what's happening, what the options are. And then consumers are driving it, and ultimately the clients we're serving have to respond to the consumer demands. And it means something different for every organization, and that's why it's so important to in the early stages identify what those goals are, because they are going to be different for each organization, and what that roadmap looks like is going to be different.
Yep. So a question came up in chat, by the way. I'm sorry, I didn't mean to overtalk you, Rachel.
Oh, no, the only thing I have to add is sustainability is becoming into our base design also. So it's not necessarily something that has to be a separate conversation. It's part of the base. It's becoming more common to be part of the base design.
Very good. So a question for you folks came through the chat. Does your team help investigate funding, grants, financing for sustainability assessments and project implementation? Do you help on the funding side?
Yeah, absolutely.
Any luck there in the dairy side that you're aware of, or has it really been in different industries?
It's
Yeah.
been a big one. Probably some of the things that jump out right away is looking at the economic development impacts. So looking at those local opportunities, as well as looking with your energy companies to see what sustainability influences or incentives there are out there on both a local, state and federal level.
Let me ask you one more, and then I'll see if I can sneak in another one for another one of our speakers. Is there kind of a top 3 that you see when people come to you and say, I've got to get some greenhouse gas numbers going here, and I'm going to renovate my plant? Do things come up over and over again? I would guess maybe lighting comes up, but maybe there's some other examples of kind of a top 3, top 5 things that are the maybe low-hanging fruit, or things that come up often.
Yeah, a big part, if we're looking at CO2 emissions specifically, anything, gas usage. So in cheese and dairy facilities, it's the boiler plant and like condensing stack economizers being added to the central plant. Looking at opportunities within the CIP systems for both water reuse, better efficiencies, hot water versus steam in those systems, which can be challenging to, for retrofit. So there's a lot of options there. Also on the wayside in dryers, for opportunities for preheaters for the combustion air, things like that. So, and then just on the water and wastewater side, a lot of opportunities for, water reuse, water conservation, and a lot of, so what we're seeing a lot of too is the wastewater problem that a plant may be experiencing. can actually be solved with a incoming water supply solution where whether it's the treatment process for the incoming water or how some of that water is used internally to fix the problem on the downstream side.
The other thing I add is that a lot of times when you first start having the conversation, we think the problem is X, and when we start looking at data and analyzing it and understanding it, the problem is not X, it's Y. So it's really important to come in and look at, you know, where things are operating, having those trend numbers, having that data so that you can establish where the biggest opportunities. And then to add to that, refrigeration is another
Yes.
huge part, and that's becoming a really good and big conversation, whether it's going to natural refrigerants or just improving your efficiency and effectiveness of your current refrigeration system.
Yeah, we've just having a recent project where there's some on the compressor side, some rework that was done that netted a $10,000 a month savings on energy costs alone.
So that's a good jump. I'm going to try to sneak another one in. Thank you, Brian and Rachel. Jumping back to Sam and Logan at Miron, you just mentioned a single issue there. Is there an anecdote on the 3D side, the augmented reality side, where you saw a dairy plant time savings that you could, without naming names, mention that you've seen, just to prove that it's happening in dairy as well as other places?
Yeah, so that precast example, John, that was a dairy plant, and we've used that at a number of different dairy plants before. The other thing that I'm noticing though, invariably these plants have some sort of steam process for that product that they're trying to get out. And while it's one thing to go through the design phase of it and figure out where things are going to go, when you start adding things in, you know, like having clean steam come into these processes and things like that, sometimes the orientation on paper doesn't necessarily work out when you start bringing in facilities operations people and things of that nature. And it's really hard for some of these team players to visualize what the engineers have laid out on these 2D documents. So putting them in the model and being able to see that stuff, the one thing that both augmented reality and virtual reality do is they allow them to see these 3D things in a one-to-one scale, right? If I just show them a model on a computer screen, it's still really hard to understand the size and complexity of the things that you're looking at. But if you look at this on an iPad while you're standing out in the actual facility, or if you have virtual reality goggles on, you're looking at things in a one-to-one scale, that really makes that communication effective. They can really understand what it is they're looking at. And that's, I think we're going to see more and more of that as things progress.
Yeah, that's a fascinating topic, and something I've seen wearing goggles myself in a plant. So it is, even a fellow like me can do it. So, well, I want to thank everyone. We'll wrap up today, and I want to remind you that what you heard today is available on the WCMA website under webinars, which is under the resource tab. You can see resources at the top and click on webinars, and you'll find all of the webinars we've done the last few years. You'll find this presentation, the PowerPoints, the speakers' contact information, and more. So check it out anytime. These are all free for your viewing as members. Finally, I'll plug the fact that next month we're going to talk about cheese sales and trends. You see the date there, June 13th at 1 p.m. And finally, once again, thanks to ISG and Miron Construction and C.D. Smith Construction. They volunteered this time, and they volunteered these very busy people to educate the industry today, and we thank them very much. So with that, I say goodbye and thanks, everyone.